Good morning, students. So last class we have been discussed about the S block, P block, D block. Now we move on to the F block elements. Right? It is also very important. So F block elements, F block elements. F block elements. Right? So here in this F block, the last electron or the differentiating electron that has been entered into the F orbital of the valence shell. So that's why these elements they have been placed in the F block, right? So if, these F block elements we are called. So the first row we are called lanthanides. First row we are called the lanthanides. There have been the series. There have been the two series, the lanthanide series and actinide series. In this lanthanide series, there have been the 14 elements, right? So that is in terms of here the cerium, right? Cerium, the 14 elements: cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Right. So there are the 14 elements. So it will be start from cerium and ends with the lutetium. Right. The first series we are called lanthanide series. Right. So second series we are called an actinide series. Actinide series, right? So it starts from thorium, proactinium, uranium, neptunium, plutonium, americum, curium, beryllium, californium, einsteinium, fermium, mendeleum, nobelium, lawrencium, right? So it starts from thorium and ends with the lawrencium. So they are called actinides. Right. So most of the elements of their actinides are radioactive elements. Right. So if we go for general electronic configuration for F blocks are nothing but in terms of here that is an n-2, right? F1 to 14, n-1, D 0 to 1, that is an ns2. This is the general electronic configuration of in terms of here. So F block element. So just remember n-2, F minimum 1 electron, maximum 14 electrons. The minimum is 1 electron, maximum is 14 electrons. And n-1 D. Here it is not 1 to 10, here it is 0 to 1. The maximum it has been filled only 1 electron in the D orbital. Maximum the remaining electrons get promoted to the F orbital. Remaining electrons get promoted to the F orbitals. Right, and ns2. So this is the general electronic configuration. So these elements are nothing but in terms of the formation of the coordinate covalent bond. Right. So and it will exhibit the color. Right. So there have been a lot of applications are there in the F block elements. Right. So this is about F block elements. Right. So we move on to the next one. So how to write the names of elements with atomic number more than 10, more than 100. Right. So how to be read the name of elements with atomic number more than 100. Right. So before that we should remember IUPAC nomenclature, IUPAC nomenclature with more than 100. So remember, before that we have to remember, right? So in terms of here, just write on here. If it is 0, right? If it is 0, we have to be write nil. We have to be write the nil, right? So if it is 1, we have to be write un, right? So if it is 1, we have to be write. So in terms of right? So if it is 2, we have to be write bi. If it is 3, we have to be write tri. If it is 4, we have to be write quad. Not tetra, it is quad. Right. So if it is 5, we have to be write pen. If it is 6, we have to be write hex. Right. So like that only we have to be write. I will tell you some 2 examples. Remaining this will be very easy. You people just try it. Okay. So you go for 101. Atomic number is 101. 101. Where 1 is nothing but un. Right. 1 will be indicate un. 0 indicate. Is I wrote on here. I wrote on there nil. And 1 it is un. Right. So that is the name is nothing but un, nil, unnium. Anil, anium. The suffix is em. You should write. Sorry. Right. Suffix. It is suffix. Suffix means end. At the end, you have to be end with the ium for all the compounds. So the suffix you should write with the ium. Right. This is an, nil, anium. Anil, anium. If you go for here, 102. 102. 102 is nothing but where 1 indicates an, 0 indicates nil, nil. Right. So this is 2 indicates by, anil, bayam, anil, bayam. Understood? It's been very easy, right? So it should not be remember. You have to be play. You have to be play with this nomenclature. Understood? Right? So come for 103. 103 elements. So that is an an, nil, trium. An, nil, trium. If we go for 104, right? So that is an an, nil, quadium. An, nil, the quadium. Right? And then the quadium, right? So if you go for like that only in terms of the 105, so that is an, nil, pentium, nil, pentium. It's been very easy and very interesting. Okay. So last time they were asking about in terms of need exam only, they were asking about the name. So 106, that is an nil, nil, hexium. Nil, hexium. That is 107. 107, nil, heptium. Nil, that is heptium. Right. So come for 108. 108, that is nil, octium. Nil, octium. That is 109. Nil, nil, inium. Nil, inium. Right. So that is 110. Right. So just remember that one. 1 indicate an, right? So 2 an, right? An, nilium. N-I-L-I-U-M. An, nilium. Understood? Right. So these have been nothing but in terms where. So 1, 2. So we'll go for few more elements. We'll go for few more elements, right? So this is. We go for triple one. Just try to yourself only. Just try to rewrite these elements. It's been very important and very easy also, right? So where we have to be represent in terms of the 0, that is nil, 1 un, 2 bi, 3 tri, 4 quad. So 5 penta and 6 hexa, 7 hepta, 8 octa, right? Like that only you have to remember. We go for 111. So that is just 1 indicate anium, right? Anium, right? It's been very easy. We'll go for 112, right? So if you write 112, so that is bayam, bayam, right? So if you go for 113, that is an trium. So we go for 114 and quadium, right? So we go for 115 and pentium, pentium. If it is 116 hexium, right? If it is 117, just tell me 117. 117. Here it is septium. It is 118. That is an octium. It's been very easy and very interesting one. Understood? Right. So these have been nothing but the elements. Right. So more than in terms of there have been 118 elements. Just around 118 elements. Right. So 118 elements. So apart from that, some other names also been there. But this is nothing but IUPAC nomenclature. Right. So Mendelium, Nobelium. There are some names also been present. Right. For these elements. So just I wrote according to the IUPAC nomenclature. Just I wrote based on the atomic number. Based on the number, we have to write the names. Understood? Right. Just carefully just write. Okay. So just remember that one. So thus 0, that is the nil. 1 un, 2 by, 3 try, 4 quad, 5 pen, and 6 hex. Right. Like that only we have to be right. Right. So come for next one. We should go for isoelectronic species. Right. So already I have been discussed in the last class only. Shall I tell one more time? Isoelectronic species. Right. So here in this isoelectronic species, so the elements like in terms of here, so that is a nitrogen. So atomic number is nothing but in terms of here the 7. Atomic number is 7. Right. So if we go for here the protons and electrons. The protons and electron. If it will come from this one, so there have been atomic number is 7, nothing but 7 protons. If it will be in terms of ions, that is 3 minus or minus 3. So we have to be add this 3 electrons and it will become the 10 electrons. So that is a nitrogen. And in terms of here, oxygen. Here atomic number is 8. We have to be add this 2 and again the 10 electrons. So here if we go for here the fluorine F minus. Atomic number of protons are 9. Right. So there have been the 10. So that is the sodium. Atomic number is 11. There have been 11 protons. And if we go for Na plus, it will indicate the loss of 1 electron. The loss of 1 electron. Thus plus indicates the deficiency of electron. Thus plus indicates the deficiency of electrons. Right. So atomic number is 11. We have to be reduced 1 electron. That is nothing but 10. So that is an Mg plus 2. An Mg plus 2 atomic number is 12. So we have to be reduced 2 electron, that is 10. The isoelectronic species are nothing but iso. The name itself indicate isoelectronic species. Isoelectronic species. Right. The species which containing the same number of electrons. The species which contain the same number of electrons but different number of protons. Right. So that one we are called isoelectronic species. Right. The name itself indicates electronic. Right. Iso means same. Electron means electron. Iso, the species which containing same number of electrons but different number of protons. That one we are called isoelectronic species. I will give one more example. Right. So I will give one more example. In competitive exams, they will ask about the isoelectronic species. Right. So they have been given some species. Yes, sir. We have to be find out whether it is an isoelectronic species or not. Right. So in Karnataka CT, NEET exam will ask. Right. It's been very important. For example, that is an Cl minus. Right. Cl minus. Before that sulfur. Right. So atomic number is nothing but in terms of here the proton and electron. Right. So there will be the 16 proton. Here it is an 18 electrons. If I go for here, so here it is the 17. Here it is an 17 protons. And if I go for here it is an 18 electrons. So that is an K plus. There have been the 19 protons. There have been how many protons? 19 protons. And here it is an 18 electrons. So that is an calcium Ca plus 2. Right. So there have been the 20 protons are in terms of 18 electrons. Right. The species, if we go for here, the 18 electrons are being common here. Right, 18 electrons are common, but number of protons are being different here. The species which contain same number of electrons but different number of protons. The species which contain same number of electrons but different number of protons. They are called isoelectronic species. They are called isoelectronic species. Understood? Right. It's been very important one. Right. We'll ask for competitive exams also. Okay. Thank you.